Okay, so I've been talking about partial fraction decomposition. So far, I've only dealt with cases where what I was decomposing were factorable on the bottom, completely factorable down to first degree polynomials. I could have something like this. Now the problem with doing a partial fraction decomposition on this one is if you look at that denominator, say, okay, well that is x plus 2 squared, so it's x plus 2 times x plus 2. Now the issue with that is, in trying to do partial fraction decomposition, if we said this, well that's not right. That's not right, because if we said that, then this would just be a plus b up here. There would be no x terms, because those are already a common denominator. You wouldn't have to multiply by anything. So it can't be just that. So in the case where you have what is called a repeating factor here, what you have is, rather than having the two just split like that, one of them would be the single factor, and the other one would be the case where that is squared. So when you have a repeated factor, and it could be x plus 2 quantity squared, it could be x squared, variety of things that it could be, then you have one term like this, the other term has the squared. So if we have that case right there, then we say, okay, well then that means in order to get common denominator, this would be x plus 2 over x plus 2. This becomes ax plus 2a plus b all over x plus 2 squared, and that's equal to x plus 3 over x plus 2 squared. And from that, x plus 3 equals ax plus 2a plus b. The x equation, coefficient of x is 1, coefficient of x is a, tells us that. And the constant equation, 3 is equal to 2a plus b. That tells me 2a, a is 1, so that's 2 plus b, thereby telling me that b is equal to a. Which then brings me back to, okay, then this equation right here could be rewritten as 1 over x plus 2 plus 1 over x plus 2 squared, and that's where this equation came from. If we were doing this as an integral, then we would look at this and say, okay, then we have two terms here. The first of these terms, as an integral, would set up as a natural log. The second one would just be u to the minus 2 du, and then that would set up as up to the power by 1 divided by it, we would get negative 1 over u. And so the integrations, as I said before, many of these end up being a natural log, but not all. This would end up just being a u to a power du, and raise the power by 1 and divide by it. So ultimately, let me go ahead and knock down my board again. Since I now know what that decomposes to, so the integral of this dx would equal the integral of 1 over x plus 2 dx plus the integral of 1 over x plus 2 squared dx. And here, u equals x plus 2, du dx equals 1, so du equals dx. This becomes the integral du over u, which integrates the natural log of u, which is natural log of x plus 2. Over here, we let u equal x plus 2. Du is still dx, same substitution we did over here, but now that integral becomes plus the integral of u to the minus 2 du. We raise the power by 1 and divide by it. That gives us u to the minus 1 over negative 1. And u is x plus 2, so that's minus. Bring the sign from there, and then just rewriting this as that. And then, of course, plus c.